The Kepler telescope was built for one purpose: to look at a certain patch in the Milky Way in search of exoplanets. The exoplanet hunter observed over hundreds of thousands of stars and discovered thousands of exoplanets during its lifetime. Liftoff of the Delta, the SER rocket, launched in 2009 as part of NASA's Discovery program, Kepler's job was to constantly scan a fixed patch of sky within our Milky Way galaxy to find planetary systems. At the time of the launch, it had the largest primary mirror ever sent into space, and it also had a 96-megapixel camera to process the light. Astronomers were interested in finding out just how many stars have planets orbiting around them, and how many of these extrasolar planets or exoplanets have conditions that are suitable for life to develop. In its 9 years in space, Kepler observed 536 stars and confirmed the existence of 2662 new exoplanets. These exoplanets are unlike anything we've ever seen in our solar system before. Most of them are significantly bigger than Earth and orbiting so close to their stars that they complete one revolution every several days. And there are some very strange worlds. Some have star-facing sides with temperatures that can melt iron and have entire hemispheres covered with oceans of liquid molten rock. Other exoplanets the size of Jupiter orbit not one, but 2 stars. If you were standing on the surface of one of these planets, you would be able to see a binary sunset. But Kepler's legacy is that it successfully found Earth-sized worlds orbiting at a safe distance from their host stars, inside what's known as a habitable zone or Goldilocks zone. This is where the temperatures are warm enough for water to condense on their surfaces, but not so cold that it will just freeze up entirely. Although being in this zone doesn't guarantee the existence of life, the presence of water is significant and the foundation of life as we know it. One such exoplanet discovered by Kepler that has recently generated excitement among researchers is called 218. In September 2019, 2 scientific teams independently announced that they found signs of liquid water in the planet's atmosphere. Situated 124 light-years away from Earth, 218 is about 8 times the mass of Earth and 3 times as big. It orbits a main-sequence red dwarf star called 218. A red dwarf star is the smallest, coolest star and by far the most common type of star in the Milky Way. According to Kepler's data, astronomers estimate that 6% of red dwarf stars have an Earth-sized planet in the Goldilocks zone, at least in our neighborhood. To find water on the surface of one such planet is a landmark discovery in the search for potentially habitable alien worlds. 218 is also the first planet with water out of all of the exoplanets discovered by Kepler in the habitable zone of stars. Kepler first discovered the planet in 2015, and since then, its composition has been studied using other telescopes, like the Spitzer and Hubble Space Telescope. Kepler mainly used what's known as the transit method for exoplanet hunting. It essentially means that if a planet passes in front of a star, the light from the star dims slightly, and that's how we can tell that there's a planet there. The level of dimming and how long it lasts gives us important information about the size and orbit of the planet. However, detecting the transit of an extrasolar planet is very challenging. For example, the diameter of Earth is only 1109 of that of the Sun. So, for an outside observer of the solar system, the passage of Earth would dim the output of the Sun by only 0.8. Kepler's cameras had to be sensitive enough to detect this minute change in the luminosity. Using the same method way back in 2014, Kepler first found a potentially habitable exoplanet. Kepler 186 ignited the imaginations of space nerds everywhere when NASA announced its discovery. Now, a new study indicates the exoplanet, 500 light-years away, may also have seasons and a climate similar to our own. New research out of Georgia Tech University has analyzed the planet's spin and actual tilt and found that its tilt is stable, like Earth's, which makes it likely that Kepler 186 also has regular seasons and a stable climate. Similar research on the massive Kepler database is going on in research universities all across the world. In fact, in recent years, previous Kepler findings that were rejected as potential Earth-sized exoplanets due to algorithmic error are getting rediscovered. These false positives are now slowly being re-analyzed in conjunction with data from other telescopes. One such planet is Kepler 1649. In mid-2020, while combing through old Kepler data and matching it against new data from the transiting exoplanet survey satellite TESS, astronomers confirmed the existence of another exoplanet with very favorable conditions for life. Kepler 1649, located 300 light-years from Earth, is very similar to Earth in size and estimated temperature. This newly revealed world is only 1.6 times larger than our own planet. Also, the amount of starlight it receives from its host star, which is also a red dwarf, is 75% of the amount of light Earth receives from our Sun, meaning the exoplanet's temperature may be similar to our planet's as well. Kepler 1649 provides yet another example of an Earth-sized planet in the habitable zone of a red dwarf star. But before we get ahead of ourselves, it's important to note that out of the 2662 exoplanets identified by Kepler, only 16 of them lie inside the Goldilocks zone. And out of these 16, some of these planets are tidally locked with their parent stars, meaning that only one hemisphere of the planet faces the star, and this is not ideal for life. Others are more like a smaller version of Neptune than a larger version of Earth. Planets similar to Neptune are expected to have a significant envelope of hydrogen surrounding any layer of water on the surface, with a planetary core of rock and iron. If the hydrogen envelope is too thick, the temperature and pressure of the water layer beneath would be far too great to support life. On top of all of this, despite being cooler, red dwarf stars tend to be more active than Sun-like stars. Thus, the planets may be exposed to higher quantities of damaging ultraviolet radiation than what we're used to here on Earth. Because of this, surface temperatures can range between 100 and 116 degrees Fahrenheit or 73 to 47 degrees Celsius. That means the surface could, on average, be colder than Antarctica or hotter than Earth's most blistering deserts. Unfortunately, we just don't have the technological know-how to study the composition and atmospheres of these alien worlds and comprehensively answer all these questions. Yet. But don't despair. Based on the statistical analysis of all the Kepler observations, astronomers now estimate that 1 in 5 stars like the Sun have planets about the size of Earth and a surface temperature conducive to life. Given that about 20% of stars are Sun-like in our galaxy, that amounts to several billions of potential habitable, Earth-like planets just in our Milky Way alone. Kepler not only focused its efforts on finding potentially habitable planets. In fact, the bulk of its discoveries were strange worlds not suitable for life but fascinating nonetheless, like the gas giants, planets composed mostly of gases such as hydrogen and helium with a relatively small rocky core. Also known as hot Jupiters, these planets orbit extremely close to their parent stars and are abundant in Kepler's data. One such fascinating example of a gas giant is Kuiper. Astronomers first flagged Kuiper as a potential planet way back in 2009. At the time, this elusive alien world was only the second planet ever found by Kepler. It slipped through the cracks a decade ago, firstly due to the enormous amount of data that Kepler generated, and secondly, because astronomers noticed that the main Kuiper star had another companion star, making analysis very difficult for them. Indeed, the Kuiper system was even more complicated than researchers realized at the time. By 2014, scientists had determined that the Kuiper system actually harbors 3 stars, and it still wasn't clear if the planet Kuiper actually existed or if the 2009 signal was generated by one of the companion stars. But thanks to additional data from the TESS satellite, scientists were able to confirm the existence of Kuiper. Planetary bodies on stable orbits in a multi-star system is quite a rare find, and the discovery of Kuiper is expected to add a lot to our understanding of planetary formation. Other exoplanet types identified by Kepler include super-Earths. They're more massive than Earth yet lighter than ice giants like Neptune and Uranus and can be made of gas, rock, or a combination of both. Lava planets super, hence, larger than Earth worlds in close, hot orbits around their parent stars. Some of them, known as Chthonian planets, are likely the remnant cores of evaporated hot Jupiters. Trojan planets of various sizes found in strange locations and sometimes even as companions to larger planets, though none have been certainly identified yet. Kepler was finally retired on the 30th of October 2018, as it ran out of fuel. The telescope was deactivated with a goodnight command sent from Mission Control the next month. Coincidentally, Kepler's retirement fell on the 338th anniversary of Johannes Kepler's death, after whom it's named. Although not operational anymore, these incredible discoveries predict a near future in which astronomers will use new and advanced telescopes on the ground and in space to more deeply understand Kepler's numerous finds. One such telescope is already slated to go up into space in 2021. The James Webb Telescope will take a much closer look at some of these Kepler objects of interest and hopefully will bring us closer to answering the question, are we alone in the universe? What do you think? Will astronomers find many more strange worlds buried inside Kepler's data? Let us know in the comments section below. There are hundreds of billions of planets caught up in the vast whirlpool of the Milky Way galaxy. From Earth, a lonely outpost floating on one of its spiral arms, humans have begun to peer across the void. Just recently, scientists have found the first Earth-sized, habitable, own world. NASA's exoplanet exploration program was created to find unmistakable signs of life on other planets. During the search for extraterrestrial life and Earth-like planets, NASA has found some incredibly bizarre alien worlds. We'll talk briefly about the planet's host star and the discovered Earth-like planets themselves. The 17,191,438 is probably one of the most fantastical cosmic objects you'll learn about here. The first thing to know is that 17,191,438 is a neutron star, a small but incredibly dense stellar object, which usually averages no more than 12 miles in diameter. Neutron stars are so dense that just 1 teaspoon of their stellar material would weigh about 1 billion tons on Earth. It's also a pulsar, which is a neutron star that emits strong beams of electromagnetic radiation from its magnetic poles and has intense magnetic fields about 1 trillion times stronger than Earth's magnetic field. Pulsars have an amazingly fast rotational spin, but 1438 is known as a millisecond pulsar that has a spin period of 5.4 milliseconds. That's about 10,000 rotations per minute. But we're talking about exoplanets here, and that's why the most impressive feature of the neutron star is its companion, 1438, which is about the same mass as Jupiter but is only about 40 the size of the gas giant. So what happened that made this planet so small and so massive? Scientists believe that 1438 is a remnant of a star that had its outer layers stripped away by the pulsar with its incredibly strong magnetic field. What's left is a planet that's composed largely of crystalline carbon, making this planet a giant diamond 5 times larger than the Earth but with a density far greater than diamonds. Another incredibly mysterious planet is orbiting just 63 light-years away from Earth, which has been named 189,733. First discovered in 2005, its blue color comes not from the reflection of an ocean like Earth, but instead a hazy, blow-torched atmosphere containing clouds laced with silicate particles. This gas giant has daytime temperatures of 2,000 degrees Fahrenheit and 4,500 mile-per-hour winds. Under these conditions, it's speculated that it may rain liquid glass sideways. The planet is only 2.9 million miles away from its parent star, so close that it is gravitationally locked, where one side always faces the star. By comparison, Mercury, the closest planet to the Sun in our solar system, is 29 million miles away. First discovered in 1999 and named after the transiting planets and planesimals small telescope used to find it, TRAPPIST is an ultra-cool red dwarf star that is slightly larger but far more massive than the planet Jupiter. It's about 39.6 light-years away from the Sun. The very first planet that NASA found that had a radius similar to Earth was Kepler 186 in 2014. 345 This discovery confirmed that Earth-sized planets do exist in the habitable zones of other stars, and it signaled a step closer to finding a world similar to our own. 345 In 2015, astronomers used NASA's Spitzer Space Telescope along with ground-based telescopes and found not 1 but 7 temperate terrestrial planets that orbit the red dwarf. These very Earth-like alien worlds are mostly rocky, and some have the potential of holding up to 250 times as much water as planet Earth. These 7 planets could lie in the optimistic habitable zone and are so close together that if you were standing on the surface of one, you could see the other planets as moons. But the red dwarf star only puts out 0.5% of the energy of our Sun, and so the planets are dark and cold, and the star is about 5.4 and 9.8 billion years old. Many more planets are being discovered every year, and in early 2020, NASA discovered a planet the same size and same distance from its star as the Earth, about 13,000 light-years away. It was found using the microlensing technique and is very cold and likely has no life. It's known as an ice ball planet and is too far away from its host star, which some scientists are now saying may not be a star at all, but a brown dwarf. Even here in our own solar system, there's the possibility for life other than on Earth. The second largest moon to Saturn and the second largest natural satellite in the solar system is Titan. It's the only other known body in space other than planet Earth where there is clear evidence of stable bodies of liquid, and usually where there is liquid water, there could be life. Titan is a planet, like Moon, that is 50 larger than our Earth's moon and is 80 more massive. It has rain, lakes, and oceans, but it's not exactly what you're imagining here on Earth. It's far more bizarre. We'll talk about that in a minute. Titan also has valleys, mountains, ridges, mesas and dunes, some of which are ice-covered deep lakes from vicious winter storms because it's far away from the Sun and only gets 1% of the sunlight Earth does. So how does it have an atmosphere with rain, ice and liquid surfaces? Titan is much colder than the Earth, with surface temperatures around minus 290 degrees Fahrenheit, minus 179 centigrade. Though it sounds like we're talking about water, Titan's atmosphere is 98 nitrogen and 2 methane, and the lakes are liquid ethane and methane. Even though its northern hemisphere is home to small liquid lakes, it's not really liquid at all. With these extremely cold temperatures, ethane and methane behave much like liquid water. However, Titan does have some warmth and may have what's called a home-baked atmosphere. What we mean by this is that organic molecules are likely cooked by the Moon's warm core, and the decay of radioactive elements may warm the Moon from within. With all this in mind, is it possible that Titan could harbor some form of exotic life forms? That might sound a little bit far-fetched, but scientists believe that Titan's atmosphere could be the perfect laboratory for studying the organic chemistry that preceded life, which provided the building blocks for life on Earth. Deposits of organic material have been found in some parts of Titan, showing proof that this giant moon could host biologically interesting compounds such as amino acids, which are the building blocks for all living things. Some scientists have regarded Titan as a deranged version of the Earth and at the same time say it resembles an infant Earth in many ways before life evolved and irrevocably changed our planet. Titan's ocean sits below a thick ice layer and is believed to have favorable conditions for life. Even though we're talking about life that exists in extremely harsh conditions, we already know of some life forms right here on Earth that can survive even in the vacuum of space, such as tardigrades that can also survive -328 degrees Fahrenheit and temperatures as high as 300 degrees Fahrenheit. They can survive radiation, boiling liquids, and massive amounts of pressure of up to 6 times the pressure of the deepest part of the ocean without any protection. If this creature can exist in all these harsh conditions, there's no telling what kind of life could exist on Titan with its extreme environment. Some astrobiologists say that because there is a lack of liquid water on Titan's surface, there probably isn't any life there. But could life exist in Titan's methane seas? If life does indeed exist on the surface of Titan, scientists have agreed that it would be microbial, either very small in size, or even single-celled organisms. But NASA thinks there's enough evidence for life and is planning to land a flying robot on the surface of the moon. We've already been to Titan before with the Cassini mission that almost everyone is familiar with. 678, and what most people don't know is that on January 14, 2005, Cassini jettisoned a small probe called Huygens, which made a spectacular film of its 2.5-hour descent to the surface. Higston Huygens landed surrounded by round blocks of ice and saw dry shorelines reminiscent of Earth and many rivers of methane. The new mission is called Dragonfly and will be the first endeavor of its kind. 1112, it's a car-sized quadcopter that is equipped with instruments capable of identifying large organic molecules. The Dragonfly is supposed to launch in 2028 and arrive at Titan in the year 2034. 1113, when the craft arrives, it will land near Titan's equator among dunes composed of solid hydrocarbon snowflakes. It will be powered by heat from radioactive plutonium. Much like NASA's Mars rover, but with its 8 rotors, it's going to be able to cover much more distance than any wheeled robot ever has. The Dragonfly drone will have to maneuver on its own, as light signals from Earth take 43 minutes to reach Titan, which makes the Dragonfly much more complicated to operate than a standard drone. The drone will use a specially designed navigation system that will help it to identify hazards and avoid them, and also be able to land autonomously. The AA that will be used on Dragonfly will be state-of-the-art. While in flight, the craft will sample the atmosphere and provide aerial images of the landscape. It'll then fly to multiple locations hundreds of miles apart, collecting data. But the ultimate destination is Sup Crater, which is the site of an ancient meteor impact where scientists say they've found evidence of liquid water, organic molecules, and the energy that could fuel chemical reactions. 14, this will be the 4th mission to be funded as part of NASA's New Frontiers program, which supports medium-sized planetary science projects that cost less than $1 billion, and Dragonfly will cost around $850 million at the time of launch. As for the future of Titan, it could become warmer in 5 billion years from now when the Sun becomes a red giant and starts the helium-burning process. As our star expands, the outer layers will swallow Mercury, Venus, and eventually the Earth. But this changing Sun may provide hope to other planets or moons, such as Titan. Surface temperatures on Titan could rise to -94 degrees Fahrenheit, high enough for stable oceans of water, ammonia mixtures to exist on its surface. As the Sun's ultraviolet output decreases, the haze in Titan's upper atmosphere will be depleted, lessening the anti-greenhouse effect on its surface and enabling the greenhouse effect created by atmospheric methane to play a far greater role. These conditions together could create an environment agreeable to exotic forms of life and will persist for several hundred million years. This was a sufficient time frame for simple life to evolve on Earth. In early 2020, NASA's Transiting Exoplanet Survey satellite test discovered an Earth-like planet named TOI 700 in its star's habitable zone and is only one of the few that exist where conditions may be just right to allow the presence of liquid water on the surface. 15, 16, 17, 18, 19, however, until more measurements are made, the exact conditions of this planet are unknown. This is where the James Webb Space Telescope will come into play. This telescope launched on December 25, 2021 and will provide improved infrared resolution and sensitivity that's far greater than the Hubble telescope. At a cost of $10 billion, it's one of the most advanced telescopes ever built. Its expensive mirrors are covered in pure gold. The James Webb Space Telescope will be able to image even the most distant events and objects in the universe, such as the formation of the first galaxies, and it's believed that there will come a day where NASA will find a planet just like ours, flourishing with life. Earth is a pretty special and unique planet. So far, we haven't found anything like it in the entire universe. But that doesn't mean a super Earth doesn't exist. In fact, they exist, and the chances are good for finding planets even better for life than our Earth. Now the hunt is on to find liquid water, because where there is water, there might be life. A new telescope is set to launch on October 31, 2021. It's packed with some amazing technology that might finally answer the big question: is there another Earth, or even a planet better than Earth, just waiting to be discovered? The human race is about to find out. Earth is the only planet we know of so far to have large bodies of liquid water on its surface, covering more than 70% of the planet. Other inner planets like Mars could have been wet early and evolved life before it became the harsh, barren world it is today. But finding liquid water on an exoplanet like the Earth, or even a super Earth, is just the beginning of our search, because if we discover liquid water on a planet's surface, the chances are good we're going to find life as well. This is because all living things need water to survive. Almost all the processes which make up life on Earth can be broken down into chemical reactions which require a liquid to break down substances. Observations from space and the ground have found water to be one of the most abundant molecules in the universe. In fact, the Japanese spacecraft Hayabusa, who recently brought back samples from an asteroid that has signatures of water and organic material. The most amazing thing found was the asteroid didn't pick it up from somewhere but is the source. This means there could be many super Earths with water just waiting to be discovered. If you want to see a video about the Hayabusa 2 mission, let us know. If we're searching for an exoplanet that's going to have liquid water, it needs to meet some criteria. For one, this planet needs to be a certain distance from its host star. If it's too far away, any water on the planet will freeze, unable to support life. And if a planet is too close to a star, everything would burn away, including oceans and any atmosphere. The interesting thing is that scientists from NASA have recently said exoplanets with oceans may be common in our Milky Way galaxy. But with the current technology we have, there isn't a way to detect liquid water on the surface of an exoplanet. Not just yet. However, there is a way to look at a planet's atmosphere and detect water vapor. And if there's water vapor in the air, chances are good it's evaporating from the ground or coming from huge oceans. In 2015, the Kepler Space Telescope found an exoplanet the size of 8 Earth masses called Q118 that orbits a red dwarf star and is located 124 light-years from Earth. Its gravity is a bit stronger than the Earth, but it's the pressure on this planet that's intense. We'll get to that later. In 2017, data from the Spitzer Space Telescope confirmed this super-Earth to be orbiting its host star in the habitable zone and taking just 33 days to complete an orbit around its star. 218 is the best candidate as a habitable planet that NASA has ever found. This is because in 2019, 2 independent research studies combining data from the Kepler, Spitzer and Hubble space telescopes found a surprising amount of water vapor in the planet's atmosphere. 24 researchers took that data and examined the spectra of starlight passing through the planet's atmosphere during transits or when the planet passed in front of its host star. 218 has a hydrogen, helium atmosphere with a high concentration of water ranging from between 20 and 50%. 24 It's even suggested that this planet has rain clouds. 218 also gets the same amount of radiation from its star as the Earth does from the Sun. So if we could travel faster than light speed, could we go live on 218? Some researchers say that the planet has a large and extremely thick atmosphere that creates high pressure conditions that might prevent life as we know it from existing. But there is also no surface for us to land on. That's because most of the planet is surrounded by a huge gas envelope. There is probably some sort of rocky core that's surrounded by a massive hydrogen gas envelope that has some water vapor in it. That means landing on this planet would be nearly impossible. And since the gas is so thick with an incredibly high pressure, any Earth-created spacecraft sent there would be destroyed, crushed, and squeezed from the millions of bars of pressure. Doesn't sound like any place we can inhabit. But don't give up hope on us finding a super Earth just yet. First discovered in 1999, TRAPPIST-1 is an ultra-cool red dwarf star with a radius slightly larger than Jupiter and lies about 39.46 light-years away from Earth. On February 22, 2017, NASA announced the discovery of 7 Earth-sized rocky worlds orbiting the single star, and every one of these planets has the potential for having water on the surface. Just a year later, in February 2018, a closer study found that these 7 planets could have more water than the oceans of the Earth, and 3 of these planets are just the right distance from the star to be warm enough for liquid water. The Hubble Space Telescope was used to find that TRAPPIST-1 are unlikely to have hydrogen, dominated atmospheres like gas giants. This makes a strong case that the two planets are rocky and possibly hold water. But both TRAPPIST and have extremely thick and hot atmospheres, somewhat like the planet Venus. But unlike Venus, these exoplanets are too hot to allow the formation of sulfuric acid clouds. It's possible both planets could be so hot their surfaces are covered in molten lava. TRAPPIST is the least massive planet in the system and likely has a compact, hydrogen, or atmosphere that is similar to Venus, Earth, and Mars. It has half the gravity of our planet, and it gets about 4.3% more sunlight from its star than Earth does, and it lies on the inner edge of the habitable zone. This planet could have oceans or layers of ice. However, a new study shows that this planet could be more like Venus, with an uninhabitable atmosphere. TRAPPIST is an exoplanet which orbits around the habitable zone and is similar to the Earth's mass, radius, gravity, and temperature. Astronomers say it has a compact atmosphere, and this one has the greatest chance of being an ocean planet like the Earth. This planet really does have the chance of being potentially habitable for life as we know it. TRAPPIST is likely a rocky world like ours, but is under a massive water, steam, gaseous envelope at very high pressure and temperature. This planet could very well have a thick ocean of liquid water covered by an atmosphere rich in abiotic oxygen. However, this exoplanet may likely be no more habitable than any other gas or ice giant with water clouds in its atmosphere. TRAPPIST could also have a thick global water ocean covered by an atmosphere containing hundreds of bars of abiotic oxygen. And TRAPPIST is a cold world with temperatures around -155 degrees Fahrenheit, similar to the Earth's South Pole, and is likely covered in ice. However, scientists say it could possibly hold liquid water. The TRAPPIST planets are all likely tidally locked, meaning that any of these planets could have a zone that's warm enough for life and doesn't get bombarded from radiation from their host star. Even though right now there are a lot of unanswered questions about the TRAPPIST system, it is the most thoroughly known planetary system apart from our own. But soon we might find out that one of these super-Earth exoplanets does have liquid water and life. The James Webb Telescope, a triumph of space science that might just be the most famous unmanned spacecraft since Sputnik, was launched on December 25, 2021, and the planets in the TRAPPIST system are the first worlds it will observe. Its main goal is making the first detailed near-infrared study of the atmosphere of a planet orbiting in the habitable zone to find signs of an atmosphere. Astronomers will use the James Webb Space Telescope's special near-infrared spectrograph, also known as a spectrometer, which disperses light from an object such as a star into a spectrum. Analyzing the spectrum of an object can tell us about its physical properties, things like the temperature, mass, and the chemical composition of the object. Atoms and molecules in the object imprint lines on its spectrum that uniquely fingerprint each chemical element present, and can even tell us about the physical conditions in the object itself. The exciting thing about the JUST is that it will be able to see oxygen in alien atmospheres of planets orbiting their stars. There are at least 4,000 exoplanets that have been found so far, and many of these are orbiting in the habitable zone. Presence of life forms such as algae, plants, and cyanobacteria here on Earth has filled our atmosphere with a vast amount of oxygen, about 20%, which is far more than our planet would have if there were no life on it. Studying the Earth helps us understand what we need to be looking for if we're going to find a super-Earth out there. And using the James Webb Space Telescope plus a new technique developed at the University of California, Riverside, researchers hope to see signs of oxygen molecules colliding with each other in the atmospheres of distant worlds. When oxygen molecules collide, they block a percentage of the infrared light that would be normally seen by telescopes. The James Webb Telescope will be able to send back data that researchers can use to determine what the chemical makeup of an alien atmosphere is. The JUST will also look at water worlds. Some of these can come too close to their star or build up heat from a runaway greenhouse effect, such as what happened to Venus, and they can lose their oceans to space. When this happens, radiation breaks apart the water into hydrogen and oxygen molecules. Hydrogen is the lightest, so it will quickly float out into space, leaving behind oxygen. Oxygen is one of the most exciting things to detect in a planet's atmosphere because of its links to life. But we don't know if life is the only thing that produces oxygen in an atmosphere. But the advanced technology and the technique will allow us to find oxygen in planets, both living or dead. Chances of mankind finding life out there look good. We just haven't had the technology to detect it until now. Are you excited for what the James Webb Space Telescope is going to find? And do you think we'll find life out there? Tell us what you think. And don't forget to stay tuned here because things are changing quickly, and it might be any day now that we finally find life and a possible super-Earth. Scientists have been finding exoplanets that could be potentially habitable for some time now. There are hundreds of millions of them out there and more found every day. There isn't a planet like ours anywhere in the universe that we know of. But now scientists say they have found exoplanets that could be more habitable than the Earth. But do they really exist? An exoplanet, or extrasolar planet, is any world that orbits a star outside of our solar system. Exoplanets can range in size from gas giants larger than Jupiter to small, rocky planets like Mars and Earth. Most of the planets that have been discovered lie in a small region of the Milky Way galaxy, and we know from observations made by NASA's Kepler Space Telescope mission that there are more planets than there are stars. The first exoplanets were discovered in the 1990s, and since then, we've discovered thousands more using several different methods. But it's not an easy task finding them. Could be at least 300 million potentially habitable exoplanets in our Milky Way galaxy alone. The US Space Agency's Kepler Space Telescope spent 9 years on a planet hunting mission and identified thousands of these exoplanets in our galaxy before it ran out of fuel in 2018. After going through all the data Kepler collected, those 300 million rocky planets could be capable of supporting liquid water on their surface. This is just a rough estimate because there are between 100 and 400 billion stars in the Milky Way, and every one of those stars probably hosts at least one planet. That means there are likely trillions of planets out there. You may think it's as simple as using a telescope to find them, but it's rare to see an exoplanet the way you would see Saturn from Earth. This is called direct imaging, and very few exoplanets have been found this way. Most exoplanets are found by using the transit method, which measures the dimming of a star as a planet passes in front of it. We can also find exoplanets by measuring the star's light spectrum for signs of a planet pulling on the star, causing the light to shift, or finding them using gravitational lensing. Using all these together is allowing us to find more exoplanets every day in the vast universe. If we're going to look for exoplanets that could support life as we know it, the first place to look is at planets that orbit their host stars in the habitable zone, or what some scientists call the Goldilocks zone. This is the area around a star where it's not too hot or too cold for liquid water to exist, but the planet also has to be the right size, and the type of star that the exoplanet orbits has to be a certain type, and it should be stable. Our own sun, a yellow dwarf, has had a stable existence for over 4.5 billion years, but this is not always the case for different stars in other systems. But we'll talk more about different types of stars in a moment. First detected by the HARPS telescope in 2016, Proxima b is the closest alien exoplanet to our solar system at 4.2 light-years from Earth. 25 it lies in the habitable zone of its red dwarf star. Proxima Centaurian was thought to be a minimum of 1.3 Earth masses, 26-27, but a new telescope named Espresso recently discovered Proxima b to be only 1.17 times more massive than our planet, making it more Earth-like than it had previously been thought and a candidate for life because it's the right distance from its host star to have liquid water. 26-27, 28 scientists believe that the planet could be habitable and future generations of super spacecraft could travel to the planet in search for life. But that same year, a massive solar flare had erupted from the red dwarf star Proxima Centauri that was 1,000 times brighter than the star itself. It hit Proxima b with 4,000 times more ultraviolet radiation than the Earth would get from a solar flare from our Sun, and researchers believe that this could have wiped out all traces of life on the planet. But Proxima b is not the only candidate as a habitable planet. Scientists now say they've discovered 24 super-habitable planets or exomoons that could be better suited for the emergence and evolution of life. The concept superhabitable came from two researchers in 2014, Ren Heller and John Armstrong, who have stated it takes much more for an exoplanet to be habitable than just being in the habitable zone. Things that would make a planet more suitable for life as we know it means they could be older, larger, warmer, wetter, could have higher levels of oxygen, and a longer, living star. Heller and Armstrong have proposed that the required size of a super-Earth would have to be 2 Earth masses, because radioactive decay in the planet's interior would last longer to provide heat, and the stronger gravity would hold onto the atmosphere longer. These 24 super-habitable exoplanets were chosen because they have a star of the right size, lifespan, and lie in the habitable zone. Many of these orbit around key dwarf stars similar to our Sun, but researchers also looked for exoplanets orbiting around key stars, orange dwarf stars that are cooler, less massive, less luminous, and there are 50 more orange dwarfs than yellow dwarfs in the Milky Way. While these Sun-like stars might not sound ideal for life, they have a big advantage. Their lifetimes are anywhere from 17 billion to 70 billion years compared to the 10 billion year lifespan of our Sun. If life started on a planet orbiting a gas star, life would have had much more time to evolve than life on Earth has so far, considering it took complex life 3.5 billion years to evolve on Earth and 4 billion years for advanced life such as humans. A larger size exoplanet could mean more space for land mass and habitat. These superhabitable worlds would also have a higher gravity and a thicker atmosphere, allowing beneficial organisms to travel through the air, spreading life. Planetary scientists say the sweet spot age of a superhabitable exoplanet is about 5 to 8 billion years. Of course, a more superhabitable planet would need water for life as we know it to survive. Planets with more moisture and an average surface temperature 8 degrees Fahrenheit warmer than Earth could make them more habitable, since we understand there is more diversity of life in warmer and wetter climates. Some of these more habitable planets could resemble the Earth in the early Carboniferous period, about 359 million years ago, when the planet had the climate of a tropical rainforest. Gliese 667 is the next closest superhabitable exoplanet, which orbits a red dwarf star in the Gliese 667 triple star system. Yes, 3 stars. If you were standing on Gliese 667, this is likely what you would see in the day sky. Gliese 667 lies 23.62 light years from Earth and is a minimum of 3.7 Earth masses. Another possible superhabitable world could be Kepler 452. It's sometimes called Earth 2.0 and orbits a G-type star which is very similar to our Sun, except that it's 1.5 billion years older and slightly bigger. Some authors speculate that there could have been an ancient civilization on the exoplanet or the Moon orbiting it, but it's possible that we're now seeing a glimpse of the future fate of Earth because the star it orbits used up its fuel and has expanded into a red giant. But there are other things that we should be looking for. So far, there has been no way to detect oxygen in an exoplanet's atmosphere. But soon, things will change. On December 25, 2021, the James Webb Space Telescope was launched into space on an Ariane 5 rocket. The technology on the telescope is unlike anything ever designed. It's the successor to the Hubble Space Telescope and will be a powerful new tool in the search and study of exoplanets that could support life. The James Webb Telescope will move out 940,000 miles away from the Earth, well beyond the orbit of the Moon, where it will set up shop and orbit the Sun. It'll be the largest observatory ever sent into orbit and will use special, cutting-edge optical science and engineering to peer into the unknown. Researchers say they've developed a new technique that will allow the James Webb Telescope to detect a unique signal produced when oxygen molecules collide. If this signal was found in an atmosphere of an exoplanet, that would mean it would have oxygen and perhaps life as we know it present on the planet's surface. Despite all this amazing technology, if a planet orbiting a red dwarf has an atmosphere similar to Earth's, it will need to be within 16 light years for the Webb telescope to detect the oxygen signal. After its 2021 launch, the James Webb Telescope will study the history of our universe, including distant exoplanets, other galaxies, and the first luminous glow of the Big Bang and the evolution of our solar system. We may need something more powerful to look farther out into space. The Nancy Grace Roman Telescope will be launched sometime in the later 2020s and will have 100 times the viewing field of the Hubble Space Telescope. 29, 30, 31, or 32, 33. It'll probe the depths of dark matter and dark energy, the mysterious and mostly unknown phenomena that make up most of the universe. The most exciting thing is it'll be able to make direct images of exoplanets, something not possible from planet Earth. But the main goal of its mission is to peer into the interior of the Milky Way galaxy, where it would possibly find thousands more exoplanets through gravitational microlensing. But if we do find life out there, we must remember the universe is fascinating and very diverse, and the best place for life, such as superhabitable worlds, might not be like Earth in any way we traditionally imagine. We're entering a very exciting time in human technology, and with the number of habitable worlds out there, it's likely that we'll finally discover life on a distant world. The Kepler Telescope was built for one purpose: to look at a certain patch in the Milky Way in search of exoplanets. The exoplanet hunter observed over hundreds of thousands of stars and discovered thousands of exoplanets during its lifetime. Liftoff of the Delta and launched in 2009 as part of NASA's Discovery program. Kepler's job was to constantly scan a fixed patch of sky within our Milky Way galaxy to find planetary systems. At the time of the launch, it had the largest primary mirror ever sent into space, and it also had a 96-megapixel camera to process the light. Astronomers were interested in finding out just how many stars have planets orbiting around them and how many of these extrasolar planets or exoplanets have conditions that are suitable for life to develop. In its 9 years in space, Kepler observed 536 stars and confirmed the existence of 2662 new exoplanets. These exoplanets are unlike anything we've ever seen in our solar system before. Most of them are significantly bigger than Earth and orbiting so close to their stars that they complete one revolution every several days. And there are some very strange worlds. Some have star-facing sides with temperatures that can melt iron and have entire hemispheres covered with oceans of liquid molten rock. Other exoplanets the size of Jupiter orbit not one but two stars. If you're standing on the surface of one of these planets, you'll be able to see a binary sunset. But Kepler's legacy is that it successfully found Earth-sized worlds orbiting at a safe distance from their host stars inside what's known as a habitable zone or Goldilocks zone. This is where the temperatures are warm enough for water to condense on their surfaces, but not so cold that it will just freeze up entirely. Although being in this zone doesn't guarantee the existence of life, the presence of water is significant and the foundation of life as we know it. One such exoplanet discovered by Kepler that has recently generated excitement among researchers is called 218. In September 2019, two scientific teams independently announced that they found signs of liquid water in the planet's atmosphere. 2023, situated 124 light-years away from Earth, 218 is about 8 times the mass of Earth and 3 times as big when it orbits a main sequence red dwarf star called 218. A red dwarf star is the smallest, coolest star and by far the most common type of star in the Milky Way. According to Kepler's data, astronomers estimate that 6% of red dwarf stars have an Earth-sized planet in the Goldilocks zone, at least in our neighborhood. Find water on the surface of one such planet is a landmark discovery in the search for potentially habitable alien worlds. 218 is also the first planet with water out of all of the exoplanets discovered by Kepler in the habitable zone of stars. 22 Kepler first discovered the planet in 2015, and since then, its composition has been studied using other telescopes like the Spitzer and Hubble Space Telescope. 21 at 24 Kepler mainly used what's known as the transit method for exoplanet hunting. It essentially means that if a planet passes in front of a star, the light from the star dims slightly, and that's how we can tell that there's a planet there. The level of dimming and how long it lasts gives us important information about the size and orbit of the planet. However, detecting the transit of an extrasolar planet is very challenging. For example, the diameter of Earth is only 1/109th of that of the Sun, so for an outside observer of the solar system, the passage of Earth would dim the output of the Sun by only 0.8%. Kepler's cameras had to be sensitive enough to detect this minor change in the luminosity. Using the same method, way back in 2014, Kepler first found a potentially habitable exoplanet. Kepler 986 ignited the imaginations of space nerds everywhere when NASA announced its discovery. Or 5 now, a new study indicates the exoplanet 500 light-years away may also have seasons and a climate similar to our own. 34 new research out of Georgia Tech University has analyzed the planet's spin and actual tilt and found that its tilt is stable like Earth's, which makes it likely that Kepler 986 also has regular seasons and a stable climate. Similar research on the massive Kepler database is going on in research universities all across the world. In fact, in recent years, previous Kepler findings that were rejected as potential Earth-sized exoplanets due to algorithmic error are getting rediscovered. These false positives are now slowly being re-analyzed in conjunction with data from other telescopes. One such planet is Kepler 1649a. In mid-2020, while combing through old Kepler data and matching it against new data from the transiting exoplanet survey satellite or TESS, astronomers confirmed the existence of another exoplanet with very favorable conditions for life. Kepler 1649a, located 300 light-years from Earth, is very similar to Earth in size and estimated temperature. Its newly revealed world is only 1.6 times larger than our own planet. Also, the amount of starlight it receives from its host star, which is also a red dwarf, is 75 of the amount of light Earth receives from our Sun, meaning the exoplanet's temperature may be similar to our planet's as well. Kepler 1649a provides yet another example of an Earth-sized planet in the habitable zone of a red dwarf star. But before we get ahead of ourselves, it's important to note that out of the 2662 exoplanets identified by Kepler, only 16 of them lie inside the Goldilocks zone. And out of these 16, some of these planets are tidally locked with their parent stars, meaning that only one hemisphere of the planet faces the star, and this is not ideal for life. Others are more like a smaller version of Neptune than a larger version of Earth, and planets similar to Neptune are expected to have a significant envelope of hydrogen surrounding any layer of water on the surface, with a planetary core of rock and iron. If the hydrogen envelope is too thick, the temperature and pressure of the water layer beneath would be far too great to support life. On top of all this, despite being cooler, red dwarf stars tend to be more active than Sun-like stars. Thus, the planets may be exposed to higher quantities of damaging ultraviolet radiation than what we're used to here on Earth. Because of this, surface temperatures can range between -100 and 116 degrees Fahrenheit, or -73 to 47 degrees Celsius. That means the surface could on average be colder than Antarctica or hotter than Earth's most blistering deserts. Unfortunately, we just don't have the technological know-how to study the composition and atmospheres of these alien worlds and comprehensively answer all these questions yet. But don't despair. Based on the statistical analysis of all the Kepler observations, astronomers now estimate that 1 in 5 stars like the Sun have planets about the size of Earth and a surface temperature conducive to life. Given that about 20 of stars are Sun-like in our galaxy, that amounts to several billions of potential habitable Earth-like planets just in our Milky Way alone. Kepler not only focused its efforts in finding potentially habitable planets, in fact, the bulk of its discoveries were strange worlds not suitable for life but fascinating nonetheless. Like the gas giants, planets composed mostly of gases such as hydrogen and helium with a relatively small rocky core. Also known as hot Jupiters, these planets orbit extremely close to their parent stars and are abundant in Kepler's data. One such fascinating example of a gas giant is Koifa-Vib. Astronomers first flagged Koifa-Vib as a potential planet way back in 2009. At the time, this elusive alien world was only the second planet ever found by Kepler. It slipped through the cracks a decade ago, firstly due to the enormous amount of data that Kepler generated, and secondly because astronomers noticed that the main Koifa-Vib star had another companion star, making analysis very difficult for them. Indeed, the Koifa system was even more complicated than researchers realized at the time. By 2014, scientists had determined that the Koifa system actually harbors 3 stars, and it still wasn't clear if the planet Koifa-Vib actually existed or if the 2009 signal was generated by one of the companion stars. But thanks to additional data from the TESS satellite, scientists were able to confirm the existence of Koifa-Vib. Planetary bodies on stable orbits in a multi-star system is quite a rare find, and the discovery of Koifa-Vib is expected to add a lot to our understanding of planetary formation. Other exoplanet types identified by Kepler include super-Earths. They're more massive than Earth yet lighter than ice giants like Neptune and Uranus, and can be made of gas, rock, or a combination of both. Lava planets, a super-dense, larger than Earth world in close, hot orbits around their parent stars. Some of them, known as Chthonian planets, are likely the remnant cores of evaporated hot Jupiters. And finally, Trojan planets, planets of various size found in strange locations and sometimes even as companions to larger planets, though none have been certainly identified yet. Kepler was finally retired on the 30th of October 2018, as it ran out of fuel. The telescope was deactivated with a good night command sent from Mission Control the next month. Coincidentally, Kepler's retirement fell on the 388th anniversary of Johannes Kepler's death, after whom it's named. Although not operational anymore, these incredible discoveries predict a near future in which astronomers will use new and advanced telescopes on the ground and in space to more deeply understand Kepler's numerous finds. One such telescope has already gone up into space in 2021. The James Webb Telescope will take a much closer look at some of these Kepler objects of interest and hopefully will bring us closer to answering the question, are we alone in the universe? What do you think? Will astronomers find many more strange worlds buried inside Kepler's data? Let us know in the comments section below. The world's oceans contain approximately 350 quintillion gallons of water, which is an astonishing amount. When we cast a bucket into the ocean, even if it comes up with just water, it doesn't indicate the absence of the flourishing ecosystems concealed beneath the waves. It's a reminder of the limitless wonders that lie within the vast cosmic realm. In the grand scheme of the universe, our explorations represent a mere fragment, and yet, they have already unveiled dozens of potentially habitable exoplanets. Today, we're delving into the mystery of the most promising Kepler worlds, imagining life on utterly alien planets. In the quest for potentially habitable planets, scientists seek out twin Earths, planets that closely resemble our own. A twin Earth is characterized by a size similar to that of Earth, which increases the probability of having a rocky surface. Additionally, it is essential for the planet to orbit a star akin in size and radiation output to our Sun, while maintaining an optimal distance within the habitable or Goldilocks zone. Kepler 452 was the first Earth-like planet found orbiting around a star like the Sun, and it might just be a perfect candidate as a habitable world. Back in 2015, scientists considered it the most Earth-like planet ever discovered, and there's a reason for that. Like the Sun, Kepler 452 is also a G-type star of about the same temperature, but 1.5 billion years old or 6 billion years old. Even though the star is brighter 120 suns brightness and slightly larger in diameter than the Sun 110 suns diameter, solar energy that reaches the exoplanet is just about 10 more than what Earth receives. At 1.6 times our planet's size, there's more than a 50 chance this super-Earth is a rocky world. Even the orbits of the two planets are similar. Kepler 452 orbital period, 385 days. Earth orbital period, 365 days. Kepler 452 is located in the habitable zone of its star, about 5 farther compared to Earth and the Sun distance. Scientists believe that the planet had a valuable head start in the development of life compared to Earth, as it spent 6 billion years in the star's habitable zone. Of course, this is only if Kepler 452 had all the right conditions for life to emerge on its surface in the first place. However, we've recently discovered that Kepler meets some of those conditions. One study shows that if the exoplanet's CO2 concentrations in the atmosphere are similar to the atmospheric amounts of the gas observed on Earth, the exoplanet is habitable. So what would it be like to live in this alien world? Because the planet is more massive than Earth, it would also likely have a stronger surface gravity. In the new environment, people would need to their altered weight, experiencing a sensation of being approximately twice as heavy as they are on our planet. Initially, humans would encounter mobility challenges, but over time we would undergo adaptation, paving the way for the natural course of evolution to unfold. Former NASA's astronaut believes that just like firefighters carrying heavy loads, our bodies would adapt to the new environment, gradually growing stronger. Through heightened physical activity, our bones would develop resilience, countering a potent gravitational force pulling us towards the ground. Over generations, kids would be born with inherently robust physiques surpassing the physical resilience of Earth-born infants. Not everything, however, would be different. Thanks to its current proximity to the star, Kepler 452 would feel much like home when it comes to sunshine and surface temperature. Plants would still rely on photosynthesis as their primary source of energy, maintaining a growth pace and intensity akin to that observed on Earth. Scientists also speculate the exoplanet might have a thick atmosphere, water on its surface, and active volcanoes. If most predictions are correct, Kepler 452 is a very promising candidate for Earth 2.0, but it might not stay like that for long. Researchers think the planet might experience a runaway greenhouse effect in about 500 million years, the same phenomenon that made Venus a scorching world by trapping high amounts of carbon dioxide in the planet's atmosphere, making it 90 times as thick as Earth's. Still, that's 500 million years, plenty enough time for the human race to colonize it and call it a homeworld. Kepler 452 seems exciting, but it's not the only Kepler world that shows promise, and it's a really distant one at that. Even light would take 1800 years to reach this exoplanet. But what if we take the fastest man-made object ever created? Breaking its own speed records as it approaches our sun, the Parker Solar Probe is soaring at a speed of 120 miles per second when under 90 ohms. This is a striking achievement, and yet, it's still only 0.63 of the speed of light. If we imagine a direct journey from Earth to the exoplanet Kepler 452, the probe would still require an astonishing 2.8 million years to traverse the vast expanse of 1800 light years. Kepler 186, 500 light years away from Earth, within the constellation Zonus, lies Kepler 186, a red dwarf star. It is this celestial location where scientists discovered the first Earth-sized exoplanet orbiting a distant star in the habitable zone. Since then, astronomers are confident there are multiple worlds in the universe similar to Earth in diameter, and could they have conditions that would allow for the existence of liquid water on their surface. Kepler 186 only exceeds the size of our planet by less than 10%. With an orbital period of 130 days, this alien world resides towards the outer boundaries of the habitable zone. Because of this, Kepler 186 receives approximately one-third of the heat energy the Earth receives from the Sun, rendering its conditions more akin to those on Mars. However, rather than being a misfortune, this disparity offers a unique advantage. Red dwarfs are known to have powerful solar flares, increasing their brightness twice within minutes. But Kepler 186 star is smaller, less massive, cooler, and nowhere near as bright as the Sun. So even if the M-type star experiences frequent outbursts of radiation, the exoplanet might be far enough to avoid the deadly consequences. The potential for liquid water and the existence of life on Kepler 186 are not solely determined by the planet's distance from its star, but also by its atmospheric conditions. The exoplanet's current position could indicate frozen water on the surface. However, its larger size allows for a denser atmosphere compared to the Earth that can retain and distribute heat, potentially warming the water. Four other planets within the system Kepler 186, Kepler 186, Kepler 186, Kepler 186 are only about half the size of our planet, and all of them have short orbital periods: 4 days, 7 days, 13 days, 22 days, which makes the inner star companions extremely hot worlds and suitable for life as we currently understand it. Today, it would take a 780-year journey to reach Kepler 186. But imagine that, sometime in the distant future, we invent a spacecraft with a speed limit of 90 the speed of light. In about 550 years, our descendants would step foot on Kepler 186. What would their experience be like? The red dwarf star Kepler 186 is smaller and about 25 times fainter than our Sun. If you were standing on the exoplanet's surface at midday, the star's brightness would be similar to our Sun's about an hour before sunset. Scientists say the planet maintains a stable axial tilt, enabling it to have regular seasons and a consistent climate, just like here on Earth. Based on calculations, scientists have determined that the axial tilt of Kepler 186 has remained stable for an extensive period of tens of millions of years. Such stability is crucial, as an erratic tilt can have catastrophic consequences, transforming a potentially habitable planet into a barren and inhospitable world. Think of Mars, where an unstable tilt might have played a key role in shaping its current unfavorable conditions. The search for the perfect Goldilocks planet continues, and some of the best candidates are often found by chance. Kepler 1649 in 2020, Kepler 1649 was accidentally discovered during a review of past observations after initially being misclassified as a false positive exoplanet. Scientists still don't know much about this world, including what its atmosphere could be. But since Kepler 1649 receives 75 of starlight compared to Earth, and because of its much shorter orbital period of just 19.5 days, it might have temperatures similar to those we experience here on our planet. Kepler 186 lacked a heat-trapping atmosphere. Its surface temperatures would be around 38-39. Although this may not seem favorable, Earth's temperatures without greenhouse gases would also be lower, around 0-18. Even if the atmospheres of the two planets were similar, Kepler 186 would still require more greenhouse gases to compensate for this difference. Many other worlds in the cosmos bear resemblances to Earth in terms of temperature or size, like TRAPPIST-1, TRAPPIST-1, Teegardens C, and TOI 700. And these exoplanets are located much closer to us. So far, Kepler 1649 seems unattainable. The vast expanse of 470,000 years of travel time lies between us. But when time comes, it would be a worthwhile journey, as none of these nearby planets can match the unique combination found in Kepler 1649. This extraordinary exoplanet not only potentially shares our planet's temperature and size characteristics, but also resides comfortably within the habitable zone of its star, making it a truly exceptional discovery. The star system has a second planet called Kepler 1649 that is roughly 8% larger than Earth, but located much closer to the red dwarf. Because of the quite unusual 4:9 orbit period ratio between the two worlds, there's potentially a third planet hiding in the system. Soon enough, next-generation observatories will give us more clues on the habitability of these worlds. Meanwhile, we'll explore yet another impressive celestial body lurking 1100 light-years away in the constellation of Lyra. Kepler 442 every 112 days, Kepler 442 orbits a Gibbsite star at about half the Earth's sun distance. Such a close proximity might lead to multiple issues for the well-being of any potential life forms present on the exoplanet. Typically, planets that orbit close to their host stars become tidally locked, resulting in a potentially harsh environment on their surfaces. However, Kepler 442 is situated just outside the range where the star's gravitational forces could cause tidal locking. Type stars are generally dimmer compared to the Sun. Additionally, Kepler 442 itself is a smaller and cooler star, so the exoplanet around it finds itself in an optimal position, approximately 0.4 astronomical units away from its relatively tranquil host star. Scientists consider G-type stars a sweet spot in the search for habitable worlds. Although they aren't as bright as G-type stars and not as long-living as M-type red dwarfs, they offer a favorable combination of properties. Only within 100 light-years of our Sun lie at least 1,000 stars. These orange dwarfs can exist between 15 to 45 billion years, and throughout the entire lifespan of our Sun, which is about 10 billion years, orange dwarfs only gain approximately 10-15 in their brightness. All the while our Sun can make the Earth uninhabitable in a mere 12 billion years. So how promising is Kepler 442? Astronomers like to categorize planets based on their potential habitability. The updated scale, called the Comparative Habitability Index, improves upon previous methods by considering multiple factors. It takes into account the planet's composition, favoring rocky planets, as well as the eccentricity of its orbit, which affects the stability of light and heat received from the star. Additionally, the scale considers the albedo, which measures the amount of solar energy reflected by the planet's atmosphere. These combined factors play a crucial role in determining habitability, even in cases where the orbit is irregular. Just like the Earth Similarity Index, the Comparative Habitability Index ranges from 0 to 1, with a higher value indicating a higher potential for habitability. On both scales, Kepler 442 has been assigned a value of approximately 0.84. Fortunately, the exoplanet is too dim and small to be directly imaged with our current telescopes, let alone travel to Kepler 442, which would take 1,700,000 years on the fastest space probe ever created. What we can do, however, is look at its biosphere. In one study dedicated to examining radiation levels received by potentially habitable exoplanets, Kepler 442 stood out as particularly interesting. It receives nearly sufficient sunshine to support a significant biosphere that could be detectable by the James Webb Space Telescope. As the JUST studies this world, we might also want it to extend its observation to two other intriguing exoplanets within the same constellation. Kepler 62 in the Kepler 62 star system, two planets reside comfortably in the habitable zone. The remaining trio of planets in the system Kepler 62, Kepler 62 and Kepler 62 orbit too closely to the Hittite star, causing them to be excessively hot and unsuitable for sustaining life. Scientists find Kepler 62 and Kepler 62 particularly intriguing as they are potentially water-rich worlds. These exoplanets have Earth similarity index rankings of 0.83 and 0.69 respectively. Kepler 62 completes an orbit around its star every 122 days, while Kepler 62 has a longer orbital period of 267 days. The atmosphere of Kepler 62 is believed to be densely clouded, and the planet is thought to have a consistently warm and humid climate extending even to its polar regions. These conditions make it an exceptionally favorable environment for supporting life. A study from 2014 suggested a possibility of a large moon in orbit of Kepler 62. If that's the case, the odds of the exoplanet being a habitable world would increase even more. This is because large moons are necessary for the evolution of complex life. Tidal forces, they help regulate the planet's rotation and axial tilt, which has a direct impact on its climate patterns. Moons also provide a protective shield, deflecting or absorbing potential impacts from asteroids or comets, thereby safeguarding the planet and its inhabitants. Although a further located Kepler 62 would mean cooler temperatures on its surface, it still holds potential to be life-friendly. But even if this hypothesis holds true, envisioning a technologically advanced civilization seems challenging, given the absence of land, metals, and the fundamental element of fire. Processes like metallurgy, vital for technological progress, would seemingly be unattainable. Nevertheless, nature's complexity opens a possibility of creatures far more inventive than ourselves, capable of finding alternative ways to surpass our current technological achievements, perhaps even if they live underwater. If humanity decided to send a message on board Parker Solar Probe to any intelligent extraterrestrial life possibly inhabiting these strange worlds, they would receive it no sooner than 1,850,000 years from now. But if we sent a radio signal today, it would reach the two exoplanets in a mere 1,200 years, a blink of an eye on a grand cosmic scale. While Kepler 62 and Kepler 62 are no ideal twin Earths today, the ever-changing nature of planetary systems holds the promise that these worlds can undergo transformative changes. Our own planet was once entirely submerged in oceans, and yet, over time, it transformed into a diverse world of both land and water. Researchers contemplate the future development of these exoplanets, speculating that they too may eventually evolve into environments reminiscent of Earth, with a harmonious interplay between expansive lands and surrounding oceans. Meanwhile, even here on Earth we have something as weird as flying fish, so it's not unreasonable to assume that were living organisms to exist on these two exoplanets, they could be quite sophisticated. One of the biggest challenges in studying distant worlds has been the vast distances involved. However, we may not have to wait for super advanced telescopes to address this challenge. Data from Kepler and the European Space Agency shows that among all Sun-like stars in the universe, half could host potentially habitable rocky worlds, and some of these stars could be lurking in our cosmic neighborhood. This means there's a 95% chance of at least one twin Earth hiding somewhere within 20 light years from us. How long do you think till we verify a completely habitable world in a close vicinity of our solar system? And how will this discovery change the course of human history? Let us know what you think in the comments. Make sure to stay tuned here to learn more about our planet and the cosmos. Thanks for watching. From a FOSS to possibly the best proof yet of life on another planet, 218 could be home to life. On April 17th of this year, NASA released data that could completely change our understanding of space. Signs of life were discovered on a distant planet with a probability of 99.7. This planet is 218, located 124 light years away from us. In its atmosphere, chemical compounds were detected that on Earth are almost always associated with living organisms. Moreover, their concentration is 1,000 times higher than on our planet. If these substances are truly the result of biological activity, as they are here on Earth, then right now there may not just be life out there, but a thriving ocean of biological diversity. Amazingly, everything points to 218 being a water world, a planet covered with deep oceans hiding active life that might be completely unlike anything on Earth. In 2015, The Kepler Space Telescope, having begun its 2-second light mission, scanned the depths of space. Over the course of this mission, it discovered more than 1,200 distant planets. Among them, one especially captured scientists' attention, a planet with mysterious signs of potential habitability. It's almost 2.5 times larger and nearly 9 times heavier than our home planet. Scientists named it 218. In 2017, the Spitzer telescope joined the research. It confirmed that 218 is located within the habitable zone of its star, precisely where liquid water could exist on the planet's surface. Almost at the same time, a scientific observatory in Chile, using the precise HARPS spectrograph, determined the planet's density, suggesting the presence of an ocean. The stakes rose. More and more signs suggested that life might exist on this planet. In 2019, the Hubble Space Telescope made a new discovery. Water vapor was detected in 218's atmosphere. Possibility of a deep, life-supporting ocean no longer seemed like science fiction. Hope became tangible. In 2023, the most powerful modern telescope, the James Webb Space Telescope, came into play. Its sensors detected something that instantly shocked scientists: traces of a chemical compound known as dimethyl sulfide DIMS, a substance that, with rare exceptions, is almost always produced by living organisms on Earth such as phytoplankton and other marine microbes. If this wasn't an error, scientists may have found signs of life beyond Earth for the first time. Still, there wasn't complete certainty. There's always a chance it could simply be a mistake. The data might have been distorted, especially since the initial measurement was taken by a single instrument, the James Webb Space Telescope's near-infrared camera, and distinguishing dimethyl sulfide from, say, methane in that range is very difficult. Scientists were faced with a reasonable question. What if it was a glitch, or a peculiar way the instrument operated? To check, NASA decided to conduct repeated observations using a different instrument and a different method. If both independent devices showed the same result, it would be possible to declare a real discovery. On April 17, 2025, the James Webb Telescope used a new instrument to perform a repeated, detailed scan of 218. This time, it was a camera operating in the mid-infrared range. The results were staggering. Signs of dimethyl sulfide were detected once again, and its concentration may be colossal, 1,000 times higher than on Earth. This isn't just any rare gas. Dimethyl sulfide is quite unusual. On Earth, it appears when microscopic algae, like phytoplankton, begin to decompose in the ocean. In the process of their decay, this gas is released, easily evaporating and rising into the atmosphere. And if you've ever walked along a seaside during windy weather, you've definitely smelled it. Dimethyl sulfide is what creates that characteristic ocean smell, impossible to confuse with anything else. But it's not just about the smell. This gas has an important property. It's very unstable in the atmosphere. It survives only for a few days, quickly destroyed by sunlight and oxygen. This means it can't just hang around. It has to be constantly replenished. And on Earth, this replenishment is almost always linked to life. That's why the discovery brought so much awe to the scientific community. The concentration of dimethyl sulfide in 218's atmosphere turned out to be 1,000 times higher than on Earth. What could this mean? Given how quickly this gas disappears, there's only one logical explanation. If its source is biological, as it is on Earth, there must be something alive on 218 and on a huge scale, enough to constantly sustain such a large amount of dimethyl sulfide in the atmosphere. Detecting this gas from 124 light-years away sounds almost like science fiction, but the James Webb Telescope made it a reality using a truly impressive method. Every time 218 passes in front of its star, part of the star's light filters through the planet's atmosphere. And although it's a tiny fraction of the light, it carries a wealth of information. The atmosphere acts like a filter, absorbing specific wavelengths of light depending on what gases are present. These changes in the light spectrum are like clues left by the planet itself, which the telescope captures and sends back to Earth. Astronomers collect these clues, analyze them, and use them to reconstruct the chemical composition of the atmosphere. In other words, we're basically reading the atmosphere of a distant planet via the light of its star. But to accurately understand what 218 may conceal, we need to look at the conditions in which it exists. The planet orbits the star 218, a cool red dwarf located 124 light-years away from Earth. Its orbit lies very close to the star, about 2.5 times closer than Mercury is to the Sun. However, the star itself is much smaller, cooler, and dimmer than our Sun. Thanks to this delicate cosmic balance, 218 receives approximately the same amount of heat and light as Earth. That's why it's considered potentially habitable. Scientists classify it as a so-called Hycean planet, a hypothetical exoplanet proposed in 2021, which could be completely covered by a deep ocean and hidden beneath a thick, hydrogen-rich atmosphere. Additionally, it was determined that there is no ammonia in 218's atmosphere, which also supports the idea that there may be a vast amount of water on the surface. Ammonia would simply dissolve into the ocean. But despite all these promising signs, there are serious doubts as well. If the planet is really encased in water, it might be too hot, so hot, in fact, that life as we know it simply couldn't exist. The temperature, pressure, and chemical environment could turn the ocean into a boiling inferno. Moreover, there's still an active debate about the true nature of the planet itself. Some scientists, including Dr. Nicholas Wogan of NASA's Research Center, believe that 218 might not be an ocean world at all, but rather a miniature gas giant without a solid surface. If that's the case, the chances of life on this planet will almost completely vanish. However, the project's lead researcher, Professor Nico Meduzadin from the University of Cambridge's Institute of Astronomy, views the situation with much greater optimism. It was his team that discovered signs of dimethyl sulfide, and he's convinced that 218 does indeed have an ocean and could be teeming with life. According to him, in the next 1 to 2 years, scientists will be able to determine with 100% accuracy whether this gas is present and whether it's a product of biological processes or some other origin. Currently, scientists estimate the probability of signs of potential life in 218's atmosphere at an impressive 99.7%. This is the highest level of reliability ever recorded in the search for biosignatures beyond Earth. In scientific statistics, this level of probable accuracy is referred to as 3 sigma out of 5, meaning the confidence level is about 99.7%. For reference, during initial observations, possible signs of biological activity were detected with only 1 sigma of confidence, about 68. But for a claim to be considered absolutely reliable by scientific standards, it needs to reach 5 sigma 99.99,994 confidence, or just 1 chance in a million that the scientists are wrong. This 5 sigma threshold was, for example, the standard required for the discovery of the Higgs boson in 2012, and the same level of precision is now expected from the data on 218. No matter how promising it all sounds, scientists at the University of Cambridge are proceeding with caution. It's still too early to declare a sensation. To confidently claim the existence of life on 218, researchers must first confirm the presence of dimethyl sulfide in its atmosphere with 99.99,994 certainty. Then they must prove that this gas indeed has a biological origin, similar to how it's produced on Earth. If this is confirmed, we would witness something truly extraordinary, the first real proof of extraterrestrial life in history. But what's even more astounding is not just the fact of its existence, but the place where it might be found. 218 is located just 124 light-years away from Earth, or about 730 trillion miles. For us humans, that distance seems absolutely insurmountable. Even trying to send a person to Mars remains a huge challenge, not to mention interstellar travel, which might forever remain beyond our reach. However, when looking at the scale of the universe itself, a distance of 124 light-years is not just small, it's barely a speck on the map. The universe stretches across 93 billion light-years, and if life is found on a planet just 124 light-years away, it would be like saying the entire universe is your homeland and the thing you've been searching for all along was in the spare room in your apartment. This would mean that if life exists out there, it could exist anywhere. Such a discovery could completely change our understanding of how widespread life might be in the cosmos. For now, it remains only a hypothesis. Research is ongoing, and despite the scientists' caution, one thing is clear: never before has humanity come so close to answering the greatest question of our existence. Are we alone in the universe? While scientists continue searching for a definitive answer, we can take a moment to glimpse into a possible future and try to imagine what life might be like on this mysterious planet if it truly exists. It makes sense to start with the simplest forms. On Earth, everything began with microscopic organisms, and most likely, life on 218 would develop in the same way. The primary candidates could be microbes capable of surviving in a hydrogen atmosphere under conditions of high pressure and temperature. They might resemble Earth's extremophiles, microorganisms living in the depths of the oceans near hydrothermal vents, where temperatures can exceed 100. These organisms do not rely on sunlight, instead deriving energy directly from chemical reactions, such as the oxidation of hydrogen sulfide. On 218, such chemical reactions could be abundant, given the hydrogen atmosphere and possible volcanic activity. If life on this planet has managed to evolve beyond microorganisms, an intriguing question arises. What might more complex life forms look like under these conditions? The deep ocean beneath a thick atmosphere would be almost completely devoid of light, meaning that vision may not be the primary sense. As on Earth's ocean floors, organisms might navigate by detecting vibrations, heat, magnetic fields, or chemical signals. Some could even develop bioluminescence, the ability to produce light, like Earth's fireflies or anglerfish. But what's especially interesting is the potential size of such creatures. In a hydrogen atmosphere, where the medium's density is lower than Earth's, organisms could have advantages for growth. Hydrogen is lighter than air, meaning the buoyant force would be greater. This could lead to the development of much larger creatures than those found on Earth. Perhaps they'd be slow-moving, with massive bodies adapted to high pressure and dense water, something like giant jellyfish or amorphous beings drifting through the warm ocean depths, or perhaps even floating within the atmosphere itself. Moreover, adaptation to colossal pressure would likely be a key feature of these beings. The ocean on 218 could be significantly deeper than Earth's, and it's quite possible that if diverse life exists, some of its representatives could comfortably live at depths of 10 to 15 miles, where the pressure could reach between 1600 and 2400 atmospheres, far exceeding the pressure at the deepest known point on Earth, the Mariana Trench. To survive under such extreme conditions, animals on 218 might possess bodies capable of withstanding immense pressure. The first thing that comes to mind is the development of a strong yet flexible outer shell that protects internal organs from pressure. These creatures might have dense, almost cartilaginous or skeletal structures made of tough biopolymers several times stronger than those found in Earth's organisms. Imagine animals with an external skeleton covered in a special material capable not only of withstanding high pressure, but also of mitigating its impact on internal tissues. These structures could resemble the frameworks of exoskeletal organisms such as crabs, but several times denser and far more resistant to deformation. Their bodies might be covered with tough biological scales or an armor that is both flexible and strong. Of course, all this is just speculation. We don't know what chemical reactions drive the metabolism of any potential life forms there, if they exist at all. We do not know which molecules play the role that dear air plays on Earth. But if the detected dimethyl sulfide is indeed being produced by biological organisms, it would mean that life there is not just possible, it's already adapted. And who knows, perhaps even now, in the warm depths of a distant ocean, creatures are slowly moving for whom our planet is as foreign and unreachable as their world is to us. Although 218 is currently considered the most promising candidate for extraterrestrial life, it's by no means the only one. Meet another fascinating planet, Teegarden Star B. It's located just 12.5 light-years away, by cosmic standards, practically next door. Scientists estimate that the chances of this planet having Earth-like conditions are about 60. Moderate temperatures, possibly ranging from 0 to 50, liquid water, and a relatively stable climate, all of these could potentially be found on Teegarden Star B. However, and this is a crucial point, such conditions, if they exist, are likely only present in a narrow transitional zone between day and night. The reason is that the planet is most likely tidally locked. It always faces its star with the same side. This means one half of the planet is in perpetual daylight, while the other remains in eternal darkness. As a result, there are extreme temperature differences, from scorching heat to freezing cold. Exactly along the boundary between these two extreme worlds is the zone of eternal twilight. A moderate climate might be maintained here, liquid water could exist, and therefore so could life, possibly even complex multicellular organisms. Another intriguing planet where life might be found is Kepler 1649. It was discovered in 2020 and lies 301 light-years away from Earth in the constellation Cygnus. Despite the distance, it has several features that make it particularly interesting to scientists. This planet orbits a small, dim star, a red dwarf that's about 5 times less massive than our Sun and 4 times smaller in size. Because of this, the planet receives about 25 as much light and heat as Earth does from the Sun. The planet itself is slightly larger than Earth, about 6 greater in radius and 20 more massive, so its gravity would feel fairly familiar, neither too strong nor too weak. However, like Teegarden Star B, Kepler 1649 likely has a major challenge to habitability. It's probably tidally locked as well. This situation could create extreme conditions, one side being too hot and the other freezing cold. Yet, just like on Teegarden Star B, in the so-called twilight zone between the two sides, a stable climate with Earth-like temperatures and the presence of liquid water might exist. In this narrow strip between light and darkness, primitive life could potentially find refuge. Heaven 100 is yet another intriguing candidate for habitability. This planet is located in the constellation Dorado, about 101 light-years from Earth, and was discovered in 2020. It's the third and outermost planet of the toy, Evan 100 star system, and perhaps the most interesting one. Unlike Teegardens star B and Kepler 1649, which are likely tidally locked and always show one side to their star, toy Evan 100 may not have become tidally locked yet. Thanks to this, toy Evan 100 could still experience day and night cycles, resulting in a more stable and life-friendly climate. The planet receives about 86 of the light that Earth gets from the Sun, lightly less, but still enough. Its surface temperature, according to calculations, should be around 4. That's cool, but not extreme, and if the planet has even a modest greenhouse effect, conditions could be much milder. In terms of size, toy Evan 100 is just slightly larger than Earth. Its mass and radius are a bit greater, meaning gravity would be somewhat stronger but still comfortable for potential life. There's another advantage. The star toy Evan 100 is relatively quiet. It doesn't produce powerful flares and storms that could destroy the planet's atmosphere, a rarity for red dwarfs, most of which are rather volatile. A calm star increases the chance of a long-lasting atmosphere, oceans, and possibly even life. Of course, we still can't say exactly what is happening on toy Evan 100's surface, but more and more evidence suggests that it's confidently making its way onto the list of the most promising exoplanets we know of. However, not all potentially interesting planets resemble Earth. Some seem to have come straight out of science fiction, and 1407 is one of the strangest planets ever discovered by scientists. 1407 is one of the weirdest planets scientists have discovered. Located about 434 light-years from Earth, this is Saturn on steroids. Studying this eerie world, astronomers struggle to measure its mass precisely, but it's believed to be around 10 to 40 Jupiter masses. 1407 is also a giant planet, much larger than the biggest planet in our solar system. What shocked scientists was the planet's ring system of enormous size. It consists of 30 rings, each the size of tens of millions of kilometers in diameter. According to rough estimates, the diameter of the entire ring system is 120 million. This is 200 times larger than the rings around Saturn. If Saturn had a ring system this big, it would dominate our night sky. Although this would have been a breathtaking view, it wouldn't last long. The rings would eventually become thinner as several satellites would form around the planet. But that's just the beginning. The universe has stored a lot more bizarre worlds for us. How can one planet be hotter than the Sun, and the other one larger than its star? How is there such a thing as a marshmallow planet? And what are planets? We've prepared a list of the most mind-blowing worlds for you. One of them is an exoplanet located 57 light-years away from Earth, dubbed G504b. It's 4 times more massive but is just about the same size as Jupiter. The weird thing about it is it's pink, quite an unusual color for a planet. So how did it get this color? The system is believed to be roughly 160 million years old, a newborn compared to our solar system. And because of the exoplanet's age, it's still changing and losing the heat of its formation, which gives it a dull magenta glow. But our universe doesn't only come in electrifying colors, it also has a lot of water-rich planets. A Neptune-like exoplanet, or the water world, has a mass of more than 8 Earths and a radius 0.24 times that of Jupiter. Although this alien world may seem promising due to its abundance of water, it's no Earth twin. The planet doesn't have a solid surface, and its atmosphere drastically differs from the one we have here. Because of extreme pressure and heat, it consists of water in a strange plasma form that behaves differently from that found on Earth. Despite the fact that the temperatures there reach 280, water on G1214me doesn't have the usual vapor, liquid and gas phases, but rather a constant supercritical fluid form. So it has some properties of both liquid and gas, but overall, it's neither and both all at once. Now let's move to the constellation Cygnus. There, about 650 light-years away, sits a scorching world, Kepler Telescope, with a mass of just 0.44 Earths and a radius 0.75 times our planet's. This is one of the hottest exoplanets known to us. The planet's star, Kepler Telescope, was once a main, equant star like our Sun, while Kepler Telescope used to be a gas giant the size of Jupiter. But about 18.5 million years ago, the star went through its red giant stage. As a result of spending a significant amount of time inside its now dead star, a hot iron core of the planet is all that's left. Scientists think the planet is still evaporating, which could eventually make it even smaller. So how hot is it? Because Kepler 70b is 65 times closer to its star than Mercury is to the Sun, the temperature on this exoplanet reaches a mind-blowing 6,650. To compare, our Sun's surface is only about 5,500. So if hell exists, it must be it. About 640 light-years away from us sits yet another scorching exoplanet dubbed WASP-76c, but that's not the only thing the planet's known for. It also has a permanent dark side and molten iron rains. Discovered in 2016, it's nearly as massive as Jupiter. Since it's tidally locked to a star, the planet faces it at all times. The temperatures on the day side reach 2350. This is more than enough to cause metals like iron to evaporate into the atmosphere. Additionally, the radiation that the day side receives is thousands of times more than our planet gets from the Sun. The dark side of WASP-76b is almost twice as cold. Due to this extreme difference in temperatures, intense winds form on this exoplanet. Because of that, the iron vapor from the hotter part of the planet is carried by the wind to the colder side, and as this vapor cools, it rains molten iron. That's odd enough, but not as odd as the planet dubbed 17,191,438b. But what's so impressive about it? This exoplanet is 3,000 times larger than its host neutron star. What's more, it wasn't always a planet. It used to be a star in the past. But let's start from the beginning. The exoplanet orbits an incredibly dense and tiny neutron star, about 20 km across. Only 1 teaspoon of this star's material would weigh billions of tons on Earth. The star is also a millisecond pulsar that emits beams of radiation, while spinning every 5.4 milliseconds. This is about 10,000 rotations per minute. The star isn't lonely, it is a companion planet about 40 the size of Jupiter, so 17,191,438a. At the same time, this alien exoplanet is more massive than Jupiter. So how come it's so small and yet so massive? This is because the exoplanet was once a star whose outer layers were stripped away by a much more massive nearby pulsar. This left a carbon remnant of a star that became a diamond world about 5 times the size of our planet. It now has a diameter of roughly 60,000 km. And because the exoplanet's proximity to the pulsar is very close, the whole system could fit within the diameter of our Sun. Space seems to be crowded with weird exoplanets, and some of them have properties so bizarre you could hardly believe these celestial bodies exist. Dubbed WASP-107, this peculiar world has the density of cotton candy, which makes scientists revise their understanding of how gas giants form. The exoplanet is about the same size as Jupiter. It's only 30 Earth masses, but Jupiter is 300 times as massive as our home planet. What's more, the core of WASP-107 is just 4 times bigger than the Earth's core, while it should be about 10 times that of our planets. Because of all this, WASP-107 has an incredibly low density. In fact, it's like a marshmallow floating in space. So far, none of these worlds seem to be giving us any hope of colonizing them. But Gliese 581 could. Finding a planet that would be suitable for life is challenging itself, and it becomes even more so because of how far away most of them are. That's why Gliese 581 looks so promising. It sits well within 20 light-years from Earth and has a mass just about 6 times the Earth's. The exoplanet is in a habitable zone of its star, so the temperature could be right for liquid water on its surface. However, because it's tidally locked, one side of Gliese 581 is always warmer than the other. But it's not all that bad. Since carbon dioxide is abundant in the planet's atmosphere, it would keep the night side from freezing. While the Earth has its own regular daylight cycle and the majority of life forms here have adapted to live under such conditions, it's a big if the same could happen on Gliese 581, given we colonize it one day. But if we do, the best idea would be to live in the region of habitability on the line that separates day and night, also called the twilight zone. The vastness of space is unimaginable, and TUMAS 2126 is living proof of that. This strange world was once thought to be a free, floating or lonely planet, but this celestial body isn't that lonely. It turns out that TUMAS 2126 moves through space along with a star, TIG 94,869,271. The weird thing is both objects have been known to astronomers for years, but nobody saw the link between them. Then scientists discovered the exoplanet and the star are both roughly 104 light-years from the Sun, which means they're connected. Later observations showed the planet orbits its star at a distance of 1 trillion. This is roughly 7,000 times the distance from our planet to the Sun. This makes it the largest orbital radius of any planet known so far. Interestingly, a result of such a huge orbit is that a year on this exoplanet equals about 900,000 Earth years. Now let's get back to our solar system for a moment. The biggest planet here has 79 moons, so it seems logical exoplanets should have exomoons too. But for years, scientists haven't been able to find any. Until now. Locating small cosmic bodies orbiting exoplanets is extremely hard. Nevertheless, astronomers have finally succeeded. But they didn't spot an exomoon. They found something even better than that. First, have a clear evidence of a moon forming disk surrounding a huge distant exoplanet named Seventic. With the help of the Kepler Telescope in Chile, scientists detected a disk in which satellites could eventually form, and its material is enough to make 3 of them, each about the size of the Earth's moon. For the first time in the history of astronomy, human beings could be observing how these small round worlds form in space, and not on a computer simulation, but live. The last exoplanet on our list is Koi 5b, and what makes this one specifically unique is not its properties, but the system it's a member of. The planet, about half the size of Saturn, was first ignored because it was complicated and even considered science fiction. A decade later, the system, named Koi 5, was given the scientific attention it deserved. It turned out astronomers stumbled across a triple star system. The planet revolves around Star A, which has a relatively close companion, Star B. They both revolve around each other every 30 years. But there's also a third, gravitationally bound star, Star C, and this one orbits stars and every 400 years. If we could somehow travel to this exoplanet and hover on the edge of this world's atmosphere with our spacecraft, we'd be seeing breathtaking and unusual things. The bottom view would be most probably filled with dark brown and grey clouds, and instead of one sun, you'd see 2, one 17 times bigger than our star and the other one quite smaller and just about 0.5% as bright as our sun. Regardless of this, the fainter star would still glow 1,000 times brighter than the full moon here on Earth. No matter how unusual these alien planets are, there could be even stranger celestial bodies in our universe. So far, planets are usually hypothetical, but some scientists believe these could actually exist. If so, such mysterious worlds would form from the collisions of gas and dust particles surrounding black holes. These planets would also evolve at great distances from supermassive black holes, making their orbits million-year long. The universe has no boundaries, not just in terms of distance, but also in terms of creativity. Now and then, astronomers discover mind-boggling space objects that broaden our limited imagination of the place we live in. It took us many years to discover all the planets of our solar system, and they're still surprising us with their properties. So who knows how much more eye-opening findings about the 5,000 known exoplanets are still ahead of us.